Hi everyone. So continuing our series on Maxwell equation. So in the last lecture we studied about the Maxwell's equation, and in the end we got a very important result that time varying magnetic field will generate electric field and time varying electric field will generate magnetic field, and this cycle will keep on going, and using that thing we are going to generate EM wave. So that EM wave we are going to generate in the next lecture, not in this lecture. In this lecture we will study this particular topic, which is Maxwell's equation in their Phasor form. Now what do you mean by Phasor form? Why it is important? Why do we need to represent Maxwell's equation in some other form? We have seen the integral form, we have seen the point form. Why do we need to generate the Maxwell equation in Phasor form? So that we are going to study, because that will help us deriving the EM wave equation. Okay, so just have a good amount of patience. Whatever that I am telling, just listen to that. Have the good amount of patience. Everything will come to you in the end of the lecture, and you will feel very good that why did we study all these kind of things. So you have to have the patience. Okay, have the patience. Another thing, have rough notebook with you at least. If you are not making your own notes, then at least have the rough notebook, because if you just listen to this lecture sitting on your table or anything, you are not going to understand any single thing. You need to have pen and paper, and whatever that I am doing here, that same thing you are going to do in your rough notebook as well. Otherwise you will not understand anything. So let's start the lecture now. So we will go to our topic, which is Maxwell's equation in their Phasor form, but before that we need to understand some basic mathematics. So have you seen this particular expression, a e to the power j theta? What do we call it? Complex exponential. If you haven't seen it, then now you can see it. We call it complex exponential. Okay, how can we write it down? E to the power j theta can be written as cos theta plus iota sin theta, and a will be multiplied. A cos theta, can I write it down as real part of a e to the power j theta or iota theta, whatever you can call it. You can call it j as well, you can call it iota as well. Let's call it j. Can I write it down as real part of a e to the power j theta, because a cos theta is the real part, and can I write it down as imaginary part of a e to the power j theta, because here imaginary part is a sin theta. Okay, so this is known as complex exponential. Let's study about this complex exponential more. We will come to this point, Maxwell's equation for static field, we will come to this point, but let's study about this. Okay, because it is important, it will be used in polarization as well. So I want to tell you what do you mean by this complex exponential. Okay, so now forget about all these diagrams. Now we are having three axes. One is the imaginary axis. Here I will make. One is the imaginary axis. Have good amount of patience and just listen to me whatever that I am telling. Imaginary axis, real axis, and one is the theta axis. Okay, all are perpendicular to each other. Imaginary, real, and theta. On theta axis you are making your sinusoid graph. On theta axis you are making sinusoid graph. As theta increases, the value of sine increases. As theta increases, value of sine increases. Now this graph you are making along imaginary axis. You are making this graph along imaginary axis. Are you able to understand? No. Let's see it. This is your imaginary axis, this is your real axis, and this is your theta. Okay, along u theta. Imaginary, real, theta. Now I am making sin theta graph. This particular graph which you can see, this graph, this is made, if we go along theta, this graph will keep on going like that. If we go along theta, this graph will increase. Like along theta, this graph will increase. This graph will run along theta. But its amplitude will walk around imaginary axis. Are you getting this point? Its amplitude will walk around imaginary axis. What do I mean by that? Let's just say if I call this direction as plus x, then this is walking around plus x and this guy is walking around minus x. Are you able to understand this point? If I call the imaginary axis as plus x, then positive amplitude is going towards plus x and negative amplitude is going towards minus x. So can I draw it something like this? Plus x, minus x, plus x, minus x. It is in the plane of imaginary and theta. It is not in the plane of real. This was your imaginary, this was your theta, right? This was your imaginary, this was your theta, and sinusoid is running here. It is not in the plane of real. It is in the plane of imaginary and theta. Is that clear to you? Same goes for cos theta. Cos theta you have drawn. Where you have drawn cos theta? Cos theta is running along theta only. As theta increases, my graph increases, but it has been drawn like this. Are you getting this point? Let's visualize this. So this was your real axis, this was your theta, right? This was your real axis, this was your theta. So along theta my cos graph will run, along theta my cos graph will run, but it will run parallel to real axis like this. Are you getting this point? From here it will start, this is the real axis, so this is the amplitude 1. From here it will start and it will run like this. Okay, this is a very critical point. Like I can tell you 99 student out of 100 student or 999 student out of 1000 student do not know about it, that what is the actual meaning of complex exponential. So that you are going to understand here, and it will help you a lot in signal systems, even in the circular polarization, everywhere it will help. So are you able to imagine that how your cos graph is going? So these graphs I have made, did you get the actual point of these graphs? There are 3 axes, imaginary, real and theta. So along the theta my sine is running, along theta only my cos is running, but the amplitude of sine is running in imaginary axis, plus imaginary minus imaginary, and amplitude of cos is running in plus real and minus real. If I call this as plus y, let's just say if I am calling this as plus y, so this amplitude is along plus y and this amplitude is along minus y. Are you able to visualize now? Okay, is that visualization clear to you? I will give you more visualization. Let's see this diagram. I am not explaining anything, I am just explaining sine and cos graph as of now. So this is my imaginary axis, this is my real axis, and this is my theta axis. So along theta I am drawing sine, along theta I am drawing sine, but amplitude is parallel to imaginary axis, amplitude is parallel to imaginary axis. Along theta I am drawing cos, but amplitude is parallel to real axis. Is that clear now? Okay, so now this visualization is more than enough, I guess. Now what we are doing, with respect to these values, we are plotting the values on, we are plotting the equivalent values. What I am doing, let me explain you. Let's just say there is a red dot here and the same red dot is here. Now I am standing on these 2 dots. Here Himanshu is standing, here Hamshakal of Himanshu is standing. Like same guys are standing and on these 2 points. Now just the way I walk here, the same way I will walk here as well. So tell me one thing, if I am standing here, so what is the amplitude of sine? 0. And if I am standing here, what is the amplitude of cos? 1. So what is the value of E j theta? That is 1. So I am here on this particular axis. Say yes or no. On real axis I am at this distance, and on imaginary axis I am at 0. On real axis I am at this distance. If I show it like a vector, if I show it by a vector, then on real axis I have this vector, and on imaginary axis I have 0 vector. So can I show it on this diagram like this, that on real axis I have this vector and on imaginary axis I have 0. So what is the equivalent vector here? What is the equivalent vector? This is the equivalent vector, right? This is the equivalent vector, because real axis this vector, on imaginary axis there is 0 vector, so equivalent vector is this vector only. Now let's just say I start walking. So if I start walking, I reach here. If on imaginary axis I reach here, that means on real axis I will reach somewhere here. So what did you get to know? That on real axis I am now somewhere here. Actually I will be somewhere here, but I am taking the projection of the point. Basically this is the graph, no? This is the graph. So actually I will be somewhere here, but I am taking the projection of the point on real axis only, because in 2D I am showing it. On real axis this is my cosinusoid graph. So actually I am at this point, but I am just taking the projection. What is this value? This value is, let's just say 1 by root 2. This was 1. So let's just say this value is 1 by root 2. So this value is 1 by root 2 here, but I am taking the projection. So on real axis I am at 1 by root 2, and on imaginary axis as well I am on 1 by root 2. On real axis I am at 1 by root 2, on imaginary axis I am at 1 by root 2. What will be the equivalent of these two? In between somewhat, right? It will be in between. And if I am showing it on imaginary and real axis only, basically on real axis you are at 1 by root 2, on imaginary axis you are at 1 by root 2. So what will be the equivalent? Somewhere here. Initial equivalent was here. The other equivalent came on this point. Or you can show, you can see it by this expression as well. What is this expression? E to the power j theta. So e to the power j theta, cos theta value is 1 by root 2 plus sin theta value is 1 by root 2. So on real axis 1 by root 2, on sin axis 1 by root 2. 1 by root 2 plus 1 by root 2. What will be the amplitude of that? 1 by 2 plus 1 by 2. What will be the amplitude? 1. Initial amplitude was also 1. Now also amplitude is 1. Now I walk more. I reach on this point. I have reached on this point. When I reach on this point, where I will reach here? Here I will reach. What is the value of sine here? 1. What is the value of cos here? 0. E to the power j theta. Value of sine is 1. Value of cos is 0. So that means on imaginary axis I am at 1 magnitude. On imaginary axis I am at 1 magnitude. Are you getting this point? Or let's see it by vector. How will I see it by vector? That on imaginary axis I am at this distance. Okay, on imaginary axis I am at this distance. But on real axis I am at 0. On real axis I am at 0. On real axis I am at 0. So what is the equivalent of this vector and 0 vector? This vector only, no? Equivalent of this vector plus 0 vector. So this vector only. So on imaginary axis you are at 1 amplitude. So yes, on imaginary axis you are at 1 amplitude. Look, this is not as straightforward as it looks like. This is a very complex concept which you are understanding here. And if you understand this point, then believe me, in EMFT you are not going to stuck anywhere. A very, very important point. Are you able to visualize what we are doing? Sinusoid graph, cosinusoid graph. We are just plotting the points by using the vectors or by using the magnitude. Let's just say I keep on walking and I reach at this point. I reach at this particular point. So if I have walked this much of lobe, so here I would have walked this much of lobe. So on real part I am at -1. On imaginary part I am at 0. Real -1, imaginary 0. That means I would have reached here. And somewhere in between I would have reached here. So in this path I will keep on walking. Just as this dot is moving on this path, just as this red dot is moving on this path in this manner, just as this red dot moves, both dots will move along this sinusoid, and both this dot will also move along this cosinusoid. So if I plot the graph on imaginary and real axis, how it will look like? The dot is moving on this circle. So when I reach at this point, so on this graph I will reach at this point, and on this graph I will reach at this point. Are you able to understand this point? From here to here I have walked. How much I have walked? 2 pi. Those who don't know, basically you can see that one complete length I have covered. So this length is 2 pi, right? One complete length I have covered. So I have walked here, and here also I have covered the one complete length. So I would have reached here. So here what is the magnitude of real? 1. And what is the magnitude of imaginary? 0. That means again I have reached this point. Are you getting this point? I am walking on this circle only. Are you able to visualize it? Let me show it here again. Look, you are somewhere here on imaginary axis, and on real axis this was your 1. So on real axis you were at 0. So what was your equivalent? On imaginary axis it was 1. When you were somewhere here, when you were somewhere in between, in between I will show, which is like this, 1 by root 2. I am showing 1 by root 2. Okay. So on imaginary axis, on real axis you were at -1 by root 2. 1 by root 2 and -1 by root 2. On imaginary axis 1 by root 2. On real axis -1 by root 2. So what was the equivalent? This was the equivalent. So when I move along the sinusoid and cosinusoid, and when I plot their resultant, it looks like a circle. But it would look like a circle if I look from here. If I am looking from my imaginary and real axis, if I am looking from here, this is my imaginary axis, this is my real axis. This is my imaginary, this is my real. If I am looking from here, then it would look like sinusoid. But if I look from 3D, if I get a 3-dimensional view, how it will look like? Like a spring. It will look like a spring. How it is looking like a spring? Are you able to understand this point? No. What did we do when we were moving along this curve? When we were moving along this particular curve, when we were moving along this curve, then what did I say? That I am taking my resultant on imaginary axis. I took this resultant here. I took the projection. Do you remember this thing? That I am taking the projection, sir. Here, this was my resultant, so I took the projection. So I took the projection by taking the equivalent of the projections. Basically, I took this vector and I took this vector. On this axis, I took this vector. On this axis, I took this vector, and then I took the resultant. So that I took the projection, but actually it was somewhere on the theta axis, right? This resultant was taking place somewhere on theta axis. I took the projection. Why did I took the projection? Because I was looking from here. If you see this spiral, if you see this spiral, and if you look from this side, what do you see? A circle. You take a spiral, and if you see only 2D, what do you see? Circle. But if you see it in 3D, what do you see? Circle is moving ahead. Do you get this point? A very important point, and this is the core concept of our e to the power j theta. What did we get to know? That it covers a cycle, then again it reaches the same point. That's why it is known as periodic function. We know our sinusoid is periodic. This is periodic. This we know. Cosinusoid is also periodic. Cosinusoid is periodic. Sinusoid is also periodic. But did you ever think why e to the power j theta is periodic? In Fourier series, in Fourier transform, and everywhere you use e to the power j theta. Why it is periodic? Why e to the power j theta is periodic? This is the reason. Because e to the power j theta is a cos theta, j a sin theta. So real axis and imaginary axis, and third axis we take theta. So along the theta, my imaginary value and my real values are going. And when I plot the equivalent of all these values, what do I get? Actually, I get a spiral. But when I look in 2D, I get a circle. Is that clear to you or not? I hope I have given the enough visualization. This will not be used in your examination. Okay, let me tell you, this will not be used in your examination as of now. For this lecture, it was not that useful, but the same concept will come when we study circular polarization. So I will there again explain this thing with better visualization. There I will try to get some animation from somewhere. I will try to get some animation. So with animation also I will explain. So if you got it, then pretty good. Even if you did not understand it, no need to worry. What you will understand, that e to the power j theta, this function is periodic. That's the only thing I wanted to deliver here. Because some people may have a doubt that why sir it is periodic. So here I have proved it. What did I say? Again, let's summarize. There is an imaginary axis, there is a real axis, because e to the power j theta has imaginary component and real component. Okay. So imaginary axis, real axis, and on theta we are running our sinusoid component and we are running our cosinusoid component. And when we take the equivalent of these, then it feels like that on imaginary and real we are going into circular. But actually we are running across theta in spiral mode. We are running across theta on spiral mode, but when we see from imaginary and real axis, it feels like that we are running in a circle. That all these points are running in a circle. Basically, what do I mean to say is that if I sit here and look, so I will feel like that this is a circle which keeps on revolving around. Say yes or no. So is that good visualization? Okay, this pic I got from internet, so credit goes to internet. I hope no one gives me copyright strike. Okay, credit goes to internet. I forgot the site, otherwise I would have mentioned the name of the site as well. Please, if someone is looking at it, please don't copyright it. Okay, so credit goes to internet. This is something that I did not draw, so I copied it from internet. Okay, so is this visualization clear to you? If it is not clear, and if you want to make it clear, then you can look back at the video and then again understand all the things which I have explained. Or otherwise you can just go by amplitude, that 1 by root 2 here, 1 by root 2 here, so equivalent is here, then 1 here, 0 here, so equivalent will be like this, real axis, then 1 on imaginary and 0 on 1 on imaginary and 0 on real, so this will be the equivalent, then 1 by root 2 on imaginary and minus 1 by root 2 on real, so this will be the equivalent, then minus 1 on real and 0 on imaginary, this will be the equivalent. So it feels like that these are the strips, or you can say these are the arrows which are revolving around. these arrows are revolving around. So if these arrows are, all arrows are of amplitude 1, and if these arrows are revolving around, then what it will make? It will make a circle, right? So this was the visualization that I wanted to give. So I hope I was able to deliver it. So the conclusion is that your e to the power j theta is a periodic signal. Why it is a periodic signal? That we have proved. Secondly, the same kind of visualization will be used when we study circular polarization, but that will come after 4 to 5 lectures. The circular polarization will come after 4 to 5 lectures. So there again I will explain all these things. I will try to explain this with better visualization, and I will try to get some animation as well. So there you will be able to visualize more that why it was known as circular polarization. Okay. So now I will ask you one question just for your general knowledge. Okay. Just for your general knowledge, what I am asking, if I create some function instead of this sine theta, if I was having this function cos theta plus iota cos theta, okay, if I was having this function cos theta plus iota cos theta, then what will this graph look like? Basically, how this will look like on imaginary axis, on real axis, what waveform we will get? Here we are getting circular, cos theta plus iota sin theta. But if it was cos theta plus iota cos theta, then how it will look like? Think about it. This is your task. I want your answer in the comment section. Okay. It will be linear, it will be ellipse, it will be circular. What it will look like? Cos theta plus iota cos theta. I want you to answer in the comment section that how this phenomena will look like. And if you did not understand this analogy, if you did not understand this animation, if you did not understand what I wanted to deliver here, then you do not need to attempt it. But if you understood that what I was trying to show here, then you should try this thing, that if my function was, this is not e to the power iota theta, if this is some random function, cos theta plus iota cos theta. So what I am doing, on imaginary axis, on theta we are running cos waveform, one is along or one is parallel imaginary axis, one is parallel real axis. And if I sit somewhere here, then what it would look like? This is my question. If I see from real and imaginary axis, if I look from here, so how it will look to me? This is something that I am asking. Is that clear to you what I am asking? Okay, I changed the random function cos theta plus iota cos theta, and now you need to tell me how it will look like, what it will look like. So solve it by vector or any analogy, whatever that you think, solve it, and then you let me know what will be the answer. Okay, so let me make it a bit clear so that when you revise the notes, it should not be so much of problem. So all this visualization is important for you. Okay, I will try to bring more and more animation in EMFT, because the same kind of things will be used when we study Smith chart. So there I will just tell that we have worked around 2 pi. So all these things there also I will teach, because I know EMFT is not that straightforward and it is taught in a very boring manner. But we will make it interesting, like very interesting we will make it. Okay, so do not worry, like the kind of concept we will deliver here, I don't want to talk about it more. Just you see the content and slowly you will realize what we are delivering here and what we are studying here. Okay, yeah, so let's move to our next topic. So from this slide, the conclusion is that a cos theta is periodic, a sin theta is periodic, and a j theta is also, a e to the power j theta is also periodic. Maxwell's equation in static field, have we studied? Yes. Maxwell's equation for time varying field, have we studied? Yes. What do you mean by static? That it is a function of space only, right? This is what you mean by static. What do you mean by time varying? So when we were studying it, what did I say? That it is a function of time. But if it is a wave, if it is electric field or if it is magnetic field, so from now onwards, if it is time varying, then certainly it has to be a function of space as well. Along with that, it will be a function of time. So time varying field means it is a function of space, along with that it is a function of time, not only the function of time. Okay, from now onwards what you are going to understand, that these are the function of space as well as time. Static field only function of space, there is no use of time. But time varying field, certainly it is a function of space, but it is also a function of time as well. Okay, so this is what I have written. What do you mean by time varying fields? So function of space as well as a function of time. So let us assume that my vector field A is a time varying field. So that means my vector field A will be a function of x, y, z and time. All good? Now in this chapter we are going to use this term electromagnetic field. So if I say electromagnetic field, then what should come in your mind? Electric field. And if I say electric field, then what should come in my mind? E. Electro stands for electric field and magnetic stands for magnetic field. So if I say magnetic field, what should come in my mind? H. So in the next lecture we will understand the meaning, but here I am just telling, if I say electromagnetic field, then electric field and magnetic field should come in your mind. Electric field is E and magnetic field is H. We will understand about electromagnetic field and EM wave in a very detailed manner in the next lecture. Okay. Now there will be a term used, time harmonic vector field. Time harmonic vector field. So if I am saying that it is a time harmonic vector field, then it will be a function of space, it will be a function of time, also it will be periodic in time. Periodic in time. And if something is periodic, then how we can represent that? If something is periodic, then we can represent that as e to the power j some angle, or cos some angle, or sine some angle. And can I call it as real part of e to the power j some angle, or real imaginary part of e to the power j some angle? So from now onwards, if I say it is a time harmonic vector field, that means it will be a function of space, it will be a function of time, and it will be represented into either sine or cos or in the terms of e to the power j something. Okay, let's see an example. This is a vector field. This is a vector field I have written. E naught cos omega t minus beta z ax cap. So is it a time harmonic vector field? Function of time, function of space, either sine, cos or e to the power j something. Sine, cos or e to the power j. What you need to see? Sine, cos or e to the power j. So function of space, function of time and cos. Yes, it is a time harmonic vector field. You will not call it time varying vector field. It is certainly a time varying vector field, but we will call it time harmonic vector field. What is the extra thing we have added? That it should be periodic in time. And if I say periodic, that means I can use e to the power j theta, cos theta and sin theta. Periodicity can be anywhere. Like you can say there are n number of periodic signals. Like there are infinite periodic signal. Why you are using only sine or cosine? Because our EM waves will be sinusoid or cosinusoid. That we will study in the next lecture. That our EM waves will be sinusoid or cosinusoid. That's why we are using here sine and cos. So what we are doing, slowly we are moving towards that topic. So just don't get irritated that sir what is going on. Everything will come to you. Okay, you need to have the patience. So now we are going to write down the phasor of a vector field. So what do you mean by phasor of a vector field and how do we write it down? Let's see that. So this is a time harmonic vector field. E naught cos omega t minus beta z, function of time, function of space, also periodic in time. So can I write it down in this manner? That it is real part of E naught e to the power j omega t minus beta z ax cap. Do you agree to this point? Because e to the power j theta, what is the real part of that? Cos theta only. So this is what I have written. E naught is constant, ax cap is also constant, so I have taken them inside. Now can I break it down something like this? E naught e to the power minus j beta z ax cap e to the power j omega t. What does this represent? This is a function of space. Function of space. And what is this? Function of time. Now this function of space, this is known as phasor representation of a vector field. Phasor representation of a vector field. Okay. So what this is known as? This is known as phasor representation of a vector field. So if I am saying that a vector field E is given, write down the phasor of that. Phasor is represented as ES, E subscript S. What is the phasor of that? You will drop real part, you will drop the time part. What you are going to drop here, real or imaginary will be written, so you are going to drop that. Also the time part you are going to drop. So these two parts you are going to drop, real and e to the power j omega t. So what you are left with? This part you are left with. So this is known as phasors of this electric field. Phasor of this electric field is Es, and which is E naught e to the power minus j beta z ex cap. Sir, what is the significance of this? We will understand. Okay, if you are having this doubt that sir, why we are calculating this particular phasor, what is the significance of that, why we are so much worried about this, so that we are going to understand. Okay, do not worry about that, have the patience. So can I write down my electric field in this manner, that my electric field E, forget about electric field, you can call it vector field as well. Okay, so this is any random vector field. So can I write it down in this manner, that it is real of Es e to the power j omega t. Do you agree to my point? Yes. This is how I can write it down. I am very excited to teach EMFT actually, because we are going to see great visualization. Okay, and you will love the subject. Like EMFT is all about formulas and derivations, rough derivation. This is what you think, right? But I will make it, I can assure you that it will be all about visualization. Just have the patience and watch all the lectures. So yeah, this is how I can represent my electric field. Have the patience that what is the physical significance of that we are going to see. So this is how I can get the phasors, and this is how I can represent my electric field now. Real part of this is just I replaced with ES. That's it. Phasor of electric field. Okay, so this is how I have replaced it, and ES is known as phasor representation of vector field E. So now this is a question, you need to find out the phasor representation of following time harmonic vector field. Is it a time harmonic vector field? Yes. Function of time, function of space, and e to the power j something. Function of time, function of space, sine. Function of time, function of space, cos. Function of time, function of space, sine. So certainly they are the time harmonic vector field. Now you need to find out the phasors. Very easy. What you will do? First one, E naught e to the power j omega t minus beta z ax cap. So what you are going to do? E naught e to the power minus j beta z ax cap, this aside, and then e to the power j. There is no real, there is no imaginary, only the time term I will drop. So only this term I will drop. So what will be my phasors? My phasor will be E naught e to the power minus j beta z ax cap. So this will be my phasor. This will be the phasor of first one. Okay. A very interesting thing we are going to notice here. E naught cos omega t minus beta z ax cap. This example we have already seen. So how you will write down? Can I write it down in this manner, that it is real part of e to the power j omega t minus beta z ax cap. You can quickly skip this part and you can write down the phasor on your own, right? Because it is very easy to write it down. E naught e to the power minus j beta z ax cap e to the power j omega t. So real and e to the power j omega t I will drop. What is the phasor? Phasor is E naught e to the power minus j beta z ax cap. This is the phasor. You see this and you see this. Okay, we will come to some conclusion. C, which is E naught sine omega t minus beta z ax cap. Can I write it down in this manner, that it is imaginary part of E naught e to the power j omega t minus beta z ax cap, right? It is just the imaginary part, because sinusoid is the imaginary part. So what I am getting here, imaginary part E naught e to the power minus j beta z ax cap e to the power j omega t. So imaginary and e to the power j omega t you will drop. What you are going to get? E naught e to the power minus j beta z ax cap. What did you see here? Phasor of all these waveforms are same. So we will come to some conclusion, okay? But let's write down the phasor of the last one. What was that? Minus E naught sine omega t minus beta z Ax cap. So first I will remove this minus sign. How I can remove this minus sign? I will convert it into cos. Yeah. So can I convert it in this manner? Do you agree? Because cos pi by 2 plus theta. In which quadrant I am going? I am going into the second quadrant. In second quadrant, cos is negative. So cos pi by 2 plus theta is minus sin theta. So I converted in this manner. Can I write it down now in this manner that it is real part of E naught e to the power j pi by 2 e to the power j omega t e to the power minus j beta z. Basically all will come in addition, pi by 2 plus omega t plus beta z. So just I separated it, Ax cap. So what we need to drop? Real and e to the power j omega t. So what will be the phasors? So phasor would be E naught. Yeah, what will be e to the power j pi by 2? I hope you know the answer. What is the answer? E to the power j pi by 2. So cos pi by 2 plus j sin pi by 2. Cos pi by 2 is 0, j sin pi by 2 is, sin pi by 2 is 1. So what is the answer? J. So this will turn out to be simple j. So let's write it down a bit bottom, that your phasor is coming out to be j E naught e to the power minus j beta z Ax cap. Okay. So this is the phasor. So this is how we can write down the phasor. So this does not represent anything, but what did you understand here? That this was my electric field. It has the phasor of this. It has the phasor of this. It has the phasor of this. So e to the power j omega t minus beta z, cos omega t minus beta z, and sin omega t minus beta z all are having the same phasor. So now if I need to go from phasor to electric field, if I need to go from here to here, how will I go? I need to go from here to here. So let's go from phasor to electric field now. From phasor representation to vector field or electric field, whatever I am saying. So this is my phasor representation. Now I need to go to my vector field. So there are three possible answers. What is the answer? That whatever the phasor you are having, along with that you connect e to the power j omega t. Whatever the phasor you are having, along with that you connect e to the power j omega t, but you write real part. Or whatever the phasor you are having, along with that you connect e to the power j omega t, but you write imaginary part. So along with phasor, if I need to go to that time harmonic vector field, from phasor representation to time harmonic vector field, I am going from phasor to time harmonic vector field. In phasor there is no term of time. So if I have suppressed the time term, what I am doing, when I was finding the phasor, that means suppressing the time term. I don't know the meaning of suppressing. Suppressing means just removing it. Okay. So suppressing the, I don't know the spelling. So I have removed the time term now. Now let's just say in some derivation I am getting this as my final answer. But I need to write down my answer not in phasor representation. I need to write down my answer in time harmonic vector field. That means I need to introduce a time term. So if I need to introduce a time term, then I can either connect e to the power j omega t, or I will connect e to the power j omega t, but I will write down real part, or I will write down imaginary part. So what I will get here? From here what I am going to get? What is my ES? ES is E naught e to the power minus j beta z e to the power j omega t. So basically this will be the answer, e to the power j omega t minus beta z. From here what you are going to get? Real part of, what is your ES? E naught e to the power minus j beta z. Ax cap is also there. Okay, don't forget Ax cap. So here also I will take Ax cap. In vector field you will get this Ax cap, only you need to suppress the time term and real imaginary. So Ax cap is also there, so don't forget that. So e to the power j omega t and Ax cap is also there. So what will be the real part of that? E naught. This will be e to the power j omega t, e to the power minus j beta z, e to the power j omega t. These will be added. Basically let me write down the step now. Real E naught e to the power j omega t minus beta z Ax cap, right? Is that clear? What will be the real part of a e to the power j omega t minus beta z? Cos. So what you are getting? E naught cos omega t minus beta z Ax cap. So from this phasor we get this representation. From this phasor we are getting this representation. From this phasor we will get another representation. What that would be? You can write that down. You can write that down on your own. Minus j beta z e to the power j omega t Ax cap. So imaginary part I need to take. So directly you can see it will be sinusoid. Okay. So 3 answers you are getting. And you can check it from the backward side as well. You can check it from backward side as well. You are having this vector field, you got this representation. You are having this vector field, you got this representation, right? Okay. Now let's see one more problem. Then we will see why we are doing all this calculation, why we are doing all these things. You will get to know. Okay. Now you must be having a doubt, sir, that sir we are doing this calculation, but what is the use of this calculation? So that we are going to see. But just before that, solve this question. Okay. Just for the practice purpose, we are solving it. So whenever you see like these terms are written, that j term is there. So let's not do it directly. First what we are going to do, we are going to convert this j. So j can be written as e to the power j pi by 2. Say yes or no. Here only we proved it. E to the power j pi by 2 is equals to j. So this I can write it down. E to the power minus j beta z Ax cap. So my phasor is E naught e to the power j pi by 2 minus beta z Ax cap. This is my phasor. Now if I need to go to that time harmonic vector field, if I need to go time harmonic vector field, then what will I do? I will add e to the power j omega t to the phasor. Just have the patience, you will realize why we are doing so. Or I can do real e to the power j omega t, imaginary yes e to the power j. All these things will help us in the derivation. Okay. In the derivation, in the next lecture, I am going to show you the derivation of EM wave. So there, all these things will help. And in this lecture as well, when we see the phasor representation of our Maxwell equation, there also it will help. Okay. So this was our ES, and e to the power j omega t will also be added. So how I can write it down? E naught e to the power j omega t minus beta z plus pi by 2 Ax cap. This will be the answer. And if you solve it, you can solve on your own. What you are going to get? That E naught cos omega t minus beta z plus pi by 2. Basically, you need to take the real part of this, right? Ax cap. You just need to take the real part of this. So what that would be? This would be the answer. And what is your cos pi by 2 plus theta? In second quadrant you are going. So minus E naught sine omega t minus beta z Ax cap. So this function you can get. Another function what you can get, you need to take imaginary part of that. So E naught sine omega t minus beta z plus pi by 2 Ax cap. So what you are going to get? E naught cos omega t. I hope you are doing all these things in your rough notebook as well, because if you don't do all these things in your rough notebook and if you just see it, you will feel like that sir, what is going, all these things are senseless. But do it in your rough notebook, all these things will make sense. So sine pi by 2 plus theta, what is that? Cos theta, right? Because in second quadrant sine is positive. So if you find the phasor of this, you will get this answer only. Okay, you find the phasor of this, you will get this answer only. You find the phasor of this, you will get this answer only. Is that clear to you? Okay, let's move ahead now. Yeah. So that was just a problem solving example. This will not help us anywhere. So let's solve this question. First, this will generate something. This will generate something fruitful. So that we are going to see now. So first you need electric field is given or any vector field is given. Time harmonic vector field is given. You need to find the phasor of E. So what will be the phasor of E? This we have already solved. A lot of times we have already solved it. What will be the phasor of E? Right? What you are going to do? Minus j beta z e to the power j omega t Ax cap. So what will be the phasor of E? That is E naught e to the power minus j beta z ax cap, just to make it equation 1. Now what you need to do, you need to differentiate with respect to time. You need to differentiate this function, which is E naught cos omega t minus beta z with respect to time. So just differentiate it. Simple differentiation. Partial differentiation we are doing. That means z will be my constant and I will be differentiating with respect to time t. So what will happen? Omega will come here. Omega E naught. What is the differentiation of cos? Minus sine. Sine minus omega t minus beta z ax cap. What you are getting here? Omega E naught minus sine. Can I write it down as cos omega t minus beta z plus pi by 2 ax cap. So this is the differentiation of d by dt. This is what you are getting, right? Do you agree to my point? Now if you need to write down the phasor of this, can you write down the phasor of this? Phasor of what you are writing? Phasor of del E by del t. This is what you need to write down. So what is your del E by del t? So here only I should write down what is my del E by del t. Omega E naught cos omega t minus beta z plus pi by 2 ax cap. Can I write it down in this manner? That real part of omega E naught e to the power j omega t e to the power minus j beta z e to the power j pi by 2 ax cap, right? So what I need to suppress? Real and e to the power j omega t. This is what I need to suppress. E to the power j pi by 2, what it will make? J. E to the power j pi by 2, it will make j. So let's write down one more step, that is j omega E naught e to the power minus j beta z ax cap e to the power j omega t. So from here if I get the phasor, what I am getting? I am getting this thing. The phasor of del E by del t. Phasor of del E by del t. What is the phasor? J omega E naught e to the power minus j beta z ax cap. From equation 1, if you have the equation 1, what do you see? E naught e to the power minus j beta z ax cap. What was that? E naught e to the power minus j beta z ax cap. It was the phasor of E. Phasor of E. So what is the conclusion you are making from here? Look, del E by del t. If you did del E by del t, it was a very hectic process, right? Del E by del t. This was a very simple expression, but if some complex expression is coming, it will be a very hectic process. Like sinusoid and cosinusoid, it will be a very hectic process. We cannot do the differentiation with respect to time again and again. But what we can do? Whatever the waveform you are having, you get the phasor of that. If differentiation is there, d by dt is there. If d by dt is there, first you get the phasor. If d by dt is there, you get j omega from that. If d by dt is there, if dou by dou t is there, then dou by dou t can be replaced with j omega, and the phasor of dou E by dou t, that will be simply j omega multiplied with the phasor of E. Are you getting this point? Phasor of E was ES and phasor of this is just multiplication. But if I write down this thing, what is that? Phasor. Okay, what we are talking about? Phasor. But if I say that my dou E by dou t is equivalent to j omega E, wrong. Not always true. Why I am saying so? Why I am saying so? Only this expression is not always true. These are always true, okay? These are always true. That with respect to phasor, you can add j omega. But if this was my E and someone is asking me del E by del t, and if I just add j omega here, that's sir, this will be my answer. That's sir, this will be my answer. Is that correct? Del E by del t, is that what you are getting? No, you are getting del E by del t as omega E naught cos omega t minus beta z plus pi by 2 e to a x cap. This is what you are getting. Is it same? No. There is huge difference. So both things are not same, right? In one special case, both things will be same. That I will tell you in what case it will be same, and you can think of it as well. There are three kind of functions. There are three kind of functions. In which of that, in sinusoid, in cosinusoid, or in exponential, in which of the cases del E by del T will be equals to j omega E? Think about it. Very easy. In cosinusoid, it will not be equal. Certainly in sinusoid also it will not be equal. It will be equal in exponential. We will prove it. Very simple derivation is there. But what did you understand here? Why we did all these kind of things? So let's write it down on this page. That if E is given, we will come back to those previous pages as well. But why we did all these kind of things? The EM wave expression can be complex. In the next lecture, we are going to study about EM wave expression. And if we do the calculation on those part, then it will be very difficult for us. So what we are going to do? First, we will suppress the time term. Suppress the time term. Or what I can say, get phasor. Both are the same thing. Suppressing the time term or getting phasor, both are the same thing. Now I need to calculate dou E by dou T. So first I will get the phasor. From here what I will get? From here, if I need to do the differentiation, so I will add j omega Es. This is the phasor of del E by del T. This is the phasor of dou E by dou T. What did I do? E was given, I got the phasor from there. I did not do any differentiation. What did I do? With respect to phasor, I just added j omega Es. What did I get? I get the phasor of dou E by dou T. I have got the phasor of dou E by dou T. Now from this phasor, I need my time harmonic vector field. From this phasor, I need my time harmonic vector field. What do I need? My time harmonic vector field. So from phasor to time harmonic vector field, how do you get that? From phasor to time harmonic vector field, how do you get that? What do you add? You can add e to the power j omega t. Or what you can add? Real j omega es e to the power j omega t. Or what you can get? You can get the imaginary part. That during the differentiation, that during the derivation we will see which part we need to take, whether we need to take real part or we need to take imaginary part or we need to take a complex exponential part. So whatever the part is required, that we will see. But did you understand what we are doing here? Why did we studied all these phasor things? Why did we study about e to the power j theta? Why did we study about from phasor to time harmonic vector field? Did you understand the whole point behind that? Let's write down the summary now. So what is the conclusion? If this is your vector field, then phasor of E can be written as this function, right? E naught can be written as real part of E naught e to the power j omega t minus beta z ax cap. So I will suppress e to the power j omega t and real. So what I will get? E naught e to the power minus j beta z ax cap. That is the phasor. What will be the phasor of dou E by dou T? Simply add j omega, or this is equals to j omega es. Simply add j omega to es. So if your E is real part of es j omega t, so what will be your dou E by dou T? Dou E by dou T will be real part of j omega es j omega t. Are you getting this point? If my E is real part of es j omega t, basically if my E is E naught cos omega t minus beta z ax cap, then how will I get dou E by dou T? So first thing I am going to do is that I will add j omega to its es. Then there are three possible functions. What is that? Add j omega t here and don't take any part, or you take real part, or you take imaginary part. But in the upper expression, here in this expression, what did I take? Real part. So here also I am taking the real part. Did you understand from here to here? How did I get? How did I come from here to here? Did you understand? I have the expression of E. I know that I am calculating the real part. Now I need to do the differentiation. So what I am going to do? I will just add j omega to its es. I will just add j omega to its phasor. Then from phasor I need to get the time harmonic vector field. So from phasor, if I need to get the time harmonic vector field, then I need to make it a function of time as well as it should be periodic. So for that what we do? We add j omega t. So one way is add j omega t, other way is add e to the power j omega t and get the real part. Third way is add e to the power j omega t, get the imaginary part. In the E, what you are getting? Real part. So here what you will get? Real part only. That's it. So it has reduced our calculation. Okay. So derivation of a vector field is equivalent to derivation of a time harmonic vector field. Again and again I am missing this thing here. So I hope you guys will understand. We are talking about time harmonic vector field now. First we studied when we were studying coordinate geometry and vector calculus, we studied about vector field and scalar field. Then we came to static vector field and a time varying vector field. Now we are coming to time harmonic vector field. Do you know the meaning of each term? Yes. Right? Vector field, simple vector field. Scalar field, simple scalar field. Then what did we studied? Then we studied about space varying. So space varying vector field or space varying vector field was function of x, y, z, and then time varying vector field was function of x, y, z and t. Then time harmonic vector field is the function of x, y, z, t, as well as it is periodic in time. Periodic in time means e to the power j theta, cos theta or sin theta. Is that clear? Yes, everything is clear. Then what is the conclusion? The main conclusion is this. The derivation I have written, differentiation, really sorry, differentiation I should have written, I have written derivation. Differentiation of a vector field with respect to time. Differentiation with respect to time, not with respect to space coordinate. It is not del o by del x. Okay, here I will write down that dou by dou x is not equivalent to j omega. This keep in mind. Differentiation with respect to time. Differentiation with respect to time is giving us j omega. Okay. So differentiation with respect to time and integration with respect to time is equivalent to dividing j omega to phasor. So if you are doing that, if you are doing dou by dou t, you get j omega, and same goes for integration. If you are doing this thing, you get 1 by j omega. There will be some function here, also there will be some function here, also there will be some function. So 1 by j omega, that function, j omega, that function. This is the summary till now. Is that clear to you? Now we will see another point. This we have already seen. So if there is a vector field, time harmonic vector field, if there is a time harmonic vector field which is E, okay, then dou E by dou t is equal to j omega E. This is not always true. I will cross it and will say not always true. So in what case it will be true? In this case. Why is that so? Just calculate dou E by dou t. Simple calculation. Forget about phasor and all these things. So this is a function of space only. There is no time term. So forget about ES. You will do the differentiation of j omega, e to the power j omega t. So what you are going to get? J omega ES e to the power j omega t. This is what you are going to get. So this is your answer of dou E by dou t. And using the phasor, if you are doing it, then how would you do? So first you will get the phasor of E. What you will get? Phasor of E. That would be ES. And what will be the phasor of dou E by dou t? That would be j omega ES. Then what you need to simply add, if you are going from phasor to time harmonic vector field, what you are going to add? J omega ES e to the power j omega t. So is that equal to dou E by dou t? Yes, this is equals to dou E by dou t. So if E is given and dou E by dou t you need to write, then simply you need to add j omega, but it will work only if your vector field is the function of exponential, complex exponential. If your vector field is a function of complex exponential, then only it will work. If it is like this, which is real part, over here I could have written imaginary part of ES j omega t, right? So if it is like that, then dou E by dou t is equals to j omega E. That is absolutely, this is wrong. Okay, but here, from here what you are getting, dou E by dou t is equals to what? J omega E only. Why this is wrong? That we have already proved here, right? All these analysis we have proved. So what is the bottom line? This is the bottom line, that if E is given, you need to find dou E by dou t. Then how will you find? First you get the phasor, then do the differentiation dou by dou t. What you will get? J omega es. From there you have got the phasor of dou E by dou t now. Now if you need the time domain function, then you have three opportunities. E to the power j omega t, take the real part or imaginary part. From three opportunities, whatever that you require, that you can pick. That's it. Is that clear? Okay. Now you must have seen Maxwell's equation for time varying fields. We have seen it, and in a lot of textbook you would have seen Maxwell's equation for phasor form. So we will write down Maxwell's equation in phasor form. So what was our first equation? Del dot d is equals to rho v. So what I'm gonna write, del dot d is equals to rho v, but in phasor form I am writing. Why I am writing in phasor form? Because I know that this function can be complex exponential or cosinusoid or sinusoid, right? It could be anything, complex exponential, sinusoid or cosinusoid. But this phasor thing, that after the differentiation you directly implement j omega, that can work only for the phasors, not for the complete time harmonic vector field. Adding j omega can only work for the phasor of time harmonic vector field. That's why I will donate, or I will represent all the equations of Maxwell's equation in which form? In phasors form. So del dot d is equals to rho v, or what I can write, del dot b is equals to 0. What is the third one? Del cross E. So del cross E, will I write E here? No. What I will write? Del cross Es. Dou by dt I am replacing with j omega. So minus j omega. Bs I will write. Is that clear to you? S I need to write. In phasor form I am writing it. In phasor form only you can replace dou by dou t is equals to j omega. I have seen n number of people doing that, dou a by dou t. Okay. So dou a by dou t is equals to, this I have written, very bad. So a lot of people do this, dou a by dou t is equals to j omega a. Absolutely wrong. I will frame my MSQ, there you can see that particular equation. So that is absolutely wrong. That will work only if your function is, or if your time harmonic vector field is complex exponential, then only it will work. Okay, otherwise it will not work. And this can be replaced with minus j omega. B is equals to mu h. I hope you remember this formula. So this is how it can be replaced. Now next is del cross h, right? Del cross h. So del cross h sigma e. Then we are having dou d by dou t. Dou d by dou t. So I can replace by j omega ds. Or how I can replace it? J omega. What is ds? Epsilon es. So can I take sigma j omega epsilon? Here also es I will write. Here also es. J omega epsilon es. So this is, you are getting del cross hs. One equation, two equation. I hope till now you must have remembered all these equations. Del dot d is equals to rho v, del dot b is equals to 0, del cross E is equals to minus j omega bs or minus j omega mu h, and del cross h is equals to sigma plus j omega e es. Okay. Now let's solve this MSQ. Take your time and tell me the correct answer. Which of the following options are correct? Considering free space. What do you mean by free space? Like b is equals to mu h I am writing, no? B is equals to mu h. So when I am doing the differentiation, I am taking this mu out. Basically I mean to say that mu is constant. This mu is constant. This is what I mean to say. It is not a function of electric field or magnetic field or any other variable. This is a constant value. Mu is constant. This is what I am saying. Okay. Mu is constant. So which of the following options are correct? Both are represented in phasor form. There is no doubt about that. Del cross E is equals to minus j omega mu hs. Here this is not the phasor form. Del cross E is equals to minus j omega mu h they have written. But what they have said, that your electric field, wait a second, you are doing differentiation with respect to h. You are doing differentiation with respect to h. Okay. Time domain differentiation, no? D by dt. D by dt has been done with respect to h. So here I should have written that my h is equals to h naught cos omega t minus theta. Yeah. Now it is correct. So differentiation is done with respect to h. So del cross E is equals to minus j omega mu h. Is that correct? Usually it is not correct, because I told you dou A by dou T is equals to j omega A only for if your A is as e to the power j omega t, then only it is true. Okay, so yeah, it is true, because my h is hs e to the power j omega t. But if it is a cos function, then it will not work, and all correct cannot be there. So A and B are correct. Are you satisfied with this explanation? Are you satisfied with the point that why did we study phasor? Why did we invest our 1 hour and 5 minutes in all these things? The first point is not usually used, that we studied about e to the power j theta. So that is not majorly used, e to the power j theta, but that was a good point which you can remember. Like you would feel very good when you study signal systems. If you know about e to the power j theta, then you will feel very good when you study signal systems. You will be able to visualize the Fourier transforms. You will be able to visualize the Fourier series. Otherwise, you will just mug up the formula. But I hope you must have understood that what is the actual meaning of complex exponential and why that is periodic. 3 axis along with theta, sine is running, cos is running, and you take all the points, you will realize that it is a circle. But it is a circle only if you are looking from imaginary and real plane. But if you are looking all the 3D, then it is like a circle is going on the theta axis. Circle is moving along theta axis, so it will be like a spring. But if you see from here, then it will look like a circle. If you see from here, it will look like a circle. Okay. And tell me one thing, if I see from here, if I see imaginary axis and time, not time, it was theta. I changed it as well, but I don't know how it got removed. It is theta. Okay, this is not time, this is theta. So if I see from imaginary axis and theta, what do I see? Sinusoid I will see, right? Imaginary plane and theta. Imaginary plane and theta. If I see from this plane, this was my imaginary, this was my theta, then sinusoid I will see. And if I see from downward means from real plane and theta. If I see from downward, real and theta, what do I see? Cosinusoid. So with respect to 3 different axes, or with respect to 3 different planes, you see 3 different waveforms. Imaginary and theta, sinusoid. Real and theta, cosinusoid. Imaginary and real, circle. Actual it is spring moving along theta. I hope now the things are getting clear to you. I will use all the phenomena when we study circular polarization. There I will try to get some simulation or some animation. Somehow in MATLAB code, I will try to code in MATLAB. Like I will not code by my own, I will get some source code, and from there I will try that somehow I will get some animation, so it will be more clear to you. Or you can try in YouTube as well, but I will do it. Don't try all these things on your own. I will do it because I am your teacher. This is my job. So yeah. So this we studied. Then we studied what is the meaning of time harmonic vector field. Electromagnetic field is electric field plus magnetic field that we are going to use in next lecture. Time varying vector field, function of time and space. And what do you mean by time? Harmonic vector field, function of time, function of space, but it will be periodic in time as well. And if it is periodic in time, then we have seen 3 functions: e to the power j something, cos something, and sine something, right? And cos and sine can be written as real and imaginary. Then we found out how to get the phasor. So we need to suppress the time term. So we just suppress the time term. We got e to the power e naught e to the power minus j beta z ax cap. But when we calculated the phasor of 3 different functions, we got the same phasor. We are getting the same phasor. So what did we understood? That from here, if you need to go here, then you can take direct e to the power j omega t, e to the power j omega t real, or e to the power j omega t imaginary, right? Then we saw the differentiation, that why did we study all these phasor and all. Then first simple mathematics we saw, nothing else, simple mathematics we saw. Then we go to know that after the differentiation, whatever that we are getting, that is same as the phasor of dou E by dou t is equals to the phasor of E into j omega. So from there I got the conclusion that if E I am having, then dou E by dou t, if the phasor of E is Es, then dou E by dou t will have a phasor of j omega Es, right? And dou E by dou t can be replaced with j omega. So in simple calculation, we can replace it with j omega. Okay, but that we can do only with phasor. Okay, if you need to do it with vector field, then your function has to be, what your function has to be? Your function has to be Es e to the power j omega t, then only you can do. If it is a real part or imaginary part, then you cannot do it. If you need to add your time harmonic, if you need to add j omega directly, then it is true only for this case. True only for this case. Then we saw the Maxwell's equation. Maxwell's equation show, and then we saw this thing which we are going to use in derivations a lot of time. And we saw the Maxwell's equation for time varying field, and then for time harmonic, then for phasor form we saw the Maxwell equation. We will write down in phasors only. These things are always true, but if you remove this s, then these equation will only be true for e to the power j omega t function. So these are true for all time harmonic vector fields. But this kind of equation, which kind of equation? This kind of equation is true only for e to the power j omega t. You have to have e to the power j omega t. If it is some real part of e to the power j omega t or some imaginary part of e to the power j omega t, then it will not work. Then you need to go from phasors only. So it will always true. It will be always true. Is that clear to you now? Okay. Now there are some basic prerequisites before understanding the EM wave, or some mathematical understanding we are going to develop. Okay, some basic mathematical understanding we are going to develop. So in this lecture only we are going to see it. It will take around, I guess, 30 to 40 minutes. So in this lecture only we are going to see it, but after a break. So I will take a break, drink some water. You can also do the same, and after that we are going to start our basic prerequisite or basic understanding of EM wave. Not EM wave. EM wave we will study in the next lecture, but some mathematical understanding we are going to develop here. Okay then. So yeah, let's take a break. After that we will start our basic understanding. Yeah, so let's start the second half. So basic mathematics we are going to see now. Okay, only mathematics we are going to see, and based on that we will get some conclusions. So what is the first question? You need to draw these graphs. Fx versus x you need to draw. Fx is equals to x. The next graph you need to draw fx is equals to x plus t for different t's. Like you will take t equals to 0, t equals to 1, t equals to 2, t equals to 3, t equals to minus 1, t equals to minus 2. In that manner you will take. So first graph is fx versus x. So fx is equals to x. This is the graph. So I hope you know the graph, how the graph goes. Very simple. Fx is equals to x. This is the graph. Now I need to draw the graph of fx equals to x plus t. So what I'm gonna do? I'm gonna take the different values of t. If I take the value of t equals to 0, t is time here. What is t? T is time. I'm gonna draw the graph of fx versus x. Charger is on. Okay. Yeah. So if I take t equals to 0, what do I get? Fx equals to x. So what do I get? Fx equals to x. If I take t equals to 1, what do I get? Fx equals to x plus 1. How do you draw fx equals to x plus 1? Slope is 1, and on y-axis it will cut at 1. So this is how you will draw. So this was the graph for t equals to 0. This was the graph for t equals to 1. And what will be the graph of t equals to 2? This will be the graph of t equals to 2. What will be the graph of t equals to minus 1? This will be the graph of t equals to minus 1. Right? At t equals to minus 1, fx is equals to x minus 1. So at y-axis it will cut at minus 1. Fx equals to x minus 1. So at y-axis it will cut at minus 1. So as the time increases, your graph is shifting upward, or you can say it is moving towards minus x direction. As the time is increasing, look, fx, if I say my time is from t equals to 0, if I say my time is starting from t equals to 0, so now where will the graph move? In this manner, graph will keep on moving. The graph is fx equals to x. If you take the time window, then graph will keep on moving like this. So graph is moving towards negative x-axis, right? Moving towards, as time increases, graph moves towards minus x-axis, right? Draw the graph for this. At t equals to 0, fx equals to x. At t equals to 1, at t equals to 0, fx is equals to x. At t equals to 1, fx is equals to x minus 1. So this is fx equals to x minus 1. This was at t equals to 0. At t equals to 1, fx equals to x minus 1. That means at y axis it will cut at 1. At y axis it will cut at 1. Now at y axis, if I take t equals to 2, if I take t equals to 2, what will happen? Fx equals to x minus 2. So at y axis it will cut at minus 2. So where the graph is going? If I take t equals to minus 1, so this will be the graph. You can draw it. At y axis it will cut at 1. At y axis it will cut at 1. So this is the graph for t equals to minus 1. So as the time increases, where you are moving? I should use red color of pen. As time increases, graph moves towards plus x, right? Plus x plus t, x minus t. If I draw minus x plus t, fx equals to minus x plus t. So try doing it on your own and let me know where it will go. So at t equals to 0, the graph is fx equals to minus x. Fx equals to minus x. The slope is negative. Now at t equals to 1, what you will get? Fx equals to minus x plus 1. So slope is the same, but at y axis it will cut at 1. So t equals to 1, t equals to 2, right? This is your t equals to 1, this is your t equals to 2. What would have been your t equals to minus 1? T equals to minus 1 would have been somewhere here. T equals to minus 1 would have been somewhere here. So as the time increases, for the last one also you can do on your own. As time increases, graph moves towards plus x, right? It is moving towards plus x, no? In this direction it is going. And what about this graph? Minus x minus t. So at t equals to 0, it is here only. But at t equals to 1, where it will be? Minus x minus 1. So at y axis it will cut at minus 1. Then t equals to minus 2. So this was t equals to 0. This was t equals to minus 1. Sorry, this was t equals to 1 and this is t equals to 2. So where you are moving? You are moving in this direction, right? So as time increases, graph, this is your fx. I hope you are able to draw these graphs. Simple mathematics. So as time increases, graph moves towards, you will get to know why we are doing all these things, okay? You will get to know when we write down the conclusion. So graph moves towards minus x, right? So see the functions first. X plus t, x minus t, minus x plus t, minus x minus t. So for x plus t, we are traveling around negative x-axis. For x plus t, we are traveling around negative x-axis. For x minus t, we are traveling around positive x-axis. For x minus t, we are traveling around positive x-axis. For minus x plus t, we are traveling around positive x-axis. And for minus x minus t, we are traveling around negative x-axis. So what is the conclusion you can make? When there is a same sign of space coordinate and time coordinate, you will move along negative axis. When there is the same sign of space and time, minus minus, plus plus, right? This is plus, this is plus, this is minus. So plus plus minus minus, same sign, that means traveling along minus x-axis, or I can say same sign means travel along minus axis only. It could be minus x, minus y, minus z, it could be anything. But if there is same sign, that means you are traveling along negative axis. And if there is opposite sign, that means you are traveling along positive axis. So will you be able to remember that? We will see this point again for a waveform. Like this was your function, right? If there is a wave, sine wave or cos wave, so in that manner also we will see, but we will get the same result there. If there is positive sign, if there are both signs are positive or both signs are same, I should not say positive, if both signs are same, then they will be moving around negative. If both are opposite, that means they are moving around positive axis. Okay, so this is the conclusion we have made. Now next question, you need to draw the following graphs. So sin x graph can you draw? Yes, simple sin x graph. Can you let me know what is this window? 2 pi. Why is that so? Sin 0 is 0. Sin pi by 2 is 1. Sin pi is 0. Sin 3 pi by 2 is minus 1. What is this? Sin 2 pi is 0. And then sin 5 pi by 2 is 1. So what is the difference between these two windows? What is the difference? 2 pi. Right? The difference is 2 pi. Right. What about sin 2x? What will be this difference? You let me know on your own. Okay? Analyze and let me know what will be this difference for sin 2x. This is 0. At sin pi by 4, x equals to pi by 4. So what you will get? Sin 2 into pi by 4. What is that? Sin pi by 2. And what is the value of sin pi by 2? 1. So this is pi by 4. What is this? Pi by 2. 2 into pi by 2, sin pi is 0. What is this? I will write down this pi by 2 a bit downward. This is your pi by 2. Pi by 2 plus pi by 4, 3 pi by 4. What is this? Pi. What is this? 5 pi by 4. So between this point and this point I am asking, what is the difference? 5 pi by 4 minus pi by 4. What is the difference? 5 by 4 minus 1 by 4. 1. So what is this difference? 2 pi. Sorry, pi. 5 pi by 4 minus pi by 4. That difference is pi. Or how I can write it? 2 pi by 2. 2 pi by 2. If this window is 2 pi, so here the window is 2 pi by 2. Or you can write down is equals to pi. Right? And if I ask you to draw the waveform of sin beta x, then what will be this length? 2 pi by beta. What did I say? What will be this length? Why length? Because you are drawing with respect to x, and x is a space coordinate. So you cannot call it time period. The 2 pi by beta, you cannot call it time period because you are drawing with respect to x, and x is a space coordinate. So what did I say? Length. So from this distance to this distance, can I call it wavelength? This is a wave, right? Now this same part is being repeated again and again. This part, then again this part, then again this part. So this part of wave is being repeated again and again. So can I call it wavelength? Wavelength. This length of wave is being repeated again and again. So I can call it wavelength, and which is shown by lambda. Why I am calling it length? Because you are drawing with respect to x. So this wavelength is equals to 2 pi by beta. This formula you have got. Lambda is equals to 2 pi by beta, or you can say beta is equals to 2 pi by lambda. So beta is known as phase constant. Okay. What beta is known as? Phase constant. Lambda is your wavelength and beta is known as phase constant. What did we get to know? That this much window is 2 pi by beta. If your graph is sin beta x, that means this much window is 2 pi by beta, and that is equivalent to wavelength. So lambda is equals to 2 pi by beta. This formula you have got. So this is the meaning of wavelength. What do you mean by wavelength? The same length of the wave is being repeated. That is your wavelength. This is your wave. So same wave is being repeated. Same wave is being repeated. This same wave is being repeated. So this is known as wavelength, which is equals to 2 pi by beta. So did you get the formula here? Beta is known as phase constant. Why it is known as phase constant? What does it represent? When we study EM wave, it will be used there. So there you will understand more. In the same manner, you draw the graph of sin t. Now your window is time. Okay. Now your window is time. So can I call it time period? Yes. Your time period is 2 pi here. Sin t, the same graph. Sin x, sin t. This window will be 2 pi. If you draw the graph of sin 2t, what will be this window? 2 pi by 2. And if you draw the graph of sin omega t, what will be this window? 2 pi by omega. From here to here, this much distance is covered, from here to here this much distance is covered, then again same distance is being covered. So how much time it took to come from same point to the same point? Basically you were at +1, then after how much time you came at +1? 2 pi by omega, and that time is known as time period, right? So here I will show that this time is known as what? T, which is your time period. That you were at +1, then again you came to +1, then from +1 to again you will go to +1, then +1 to again you will go to +1. How much time you are taking? This waveform is being repeated, no? This certain waveform is being repeated. So how much time you are taking? 2 pi by omega. So this T is equals to 2 pi by omega. Or another formula you are getting, omega equals to 2 pi by T. So in no time you have got two formulas, and you would have understood the meaning as well. That what is the meaning of T? T is time period, which we already know, but that is equivalent to 2 pi by omega. Why it is equivalent? We draw the graph, we get to know that this window is 2 pi by omega. So T is equals to 2 pi by omega. And here this was the wavelength, because we were drawing with respect to x. So this we can call as wavelength, and this is equal to 2 pi by beta. Beta is phase constant, lambda is the wavelength, T is the time period. Omega is known as angular frequency. Okay, angular frequency. We call it angular frequency. These terms will be again introduced, but here I wanted to give the basics, that how do you get these formulas. I hope you would be already knowing these formulas. You must have studied it, but that's the actual meaning. Okay, so here I am not going to write down what do you mean by wavelength, what is the definition of wavelength, but we know the meaning of wavelength. The same length of wave is being repeated, that is your wavelength, right? And that is equals to 2 pi by beta. And what is your time period? The same wave is being repeated after how much time? So after T time, and that is equals to 2 pi by omega. That's it. Now there is a question, again there is a question. So a wave equation is given, E is equals to E naught cos omega t minus beta z. Beta is the phase constant and omega is the angular frequency of the wave. You need to draw E versus z taking time t equals to 0. And then you need to draw E versus t taking time z equals to 0. Very easy question. But if you see this waveform, what you can comment? What did I tell you? Is this your time harmonic vector field? No, first thing, it is not vector field. It is my time harmonic scalar field. This is your time harmonic scalar field, because there is no vector quantity. I will associate the vector quantity in the next problem, but in this problem there is no vector quantity, right? So this equation represents a field traveling in which direction? Can you tell me? T and Z both have opposite sign. What is written here? Z. So this is the wave traveling in, if both have opposite sign, that means plus Z direction. We will see the waveform, you will understand more. In the next question, we will see the waveform, that how it is traveling in positive Z direction, but with respect to this reference, whatever the time we spent here, with respect to this reference, can you tell me that this waveform will be traveling in positive Z direction, because time component and Z component both have opposite sign, plus Z direction, with the wavelength of what? 2 pi by beta, right? What is this beta? So what will be the wavelength? Lambda is equals to 2 pi by beta. And the time period of, because here there is no term of lambda, so that's why I am writing in terms of, here I could have wrote that it is traveling in positive Z direction with lambda wavelength, but in the equation there is no lambda. What is lambda? 2 pi by beta. And how much time period? 2 pi by omega time period. Because there is no term of t, I could have written that it is traveling with t time period, but t is equals to 2 pi by omega. So is that clear to you? Now let me know what will be your first question. You need to draw E versus Z taking t equals to 0. If I put t equals to 0 here, what do I get? E is equals to E naught cos, if I put t equals to 0, minus beta z, right? So cos minus theta, I hope you remember, cos minus theta. In first lecture we saw all these things, that is equals to cos theta. Okay, cos minus theta is equals to cos theta. So what you are getting? E naught cos beta z. Second, if you put z equals to 0, what you are getting? E is equals to E naught cos omega t. Can you draw these two graphs? E naught cos beta z with respect to z, and E naught cos omega t with respect to t. Can I draw this graph? Yes. Very simple. This I am calling as E1. This I am calling as E1. This I am calling as E2. So your E1 is cos beta z and your E2 is cos omega t, right? E2 is E naught cos omega t, E1 is E naught cos beta z. From peak to peak, if we check, what is this length? Cos beta z, what is this length? 2 pi by beta, right? This I will call length because z is length and t is time. So can I call it, what is this time window? Yes, that time window is 2 pi by omega. Now this wave you have drawn taking time t equals to 0. If time increases, then this wave will start traveling. Look, this is the picture you have clicked at t equals to 0. If time increases, in my stopwatch, if I increase the time, then this wave will start traveling. So this is traveling with some velocity, right? Now what you know, that in 2 pi by omega time, it is covering the distance of 2 pi by beta. Say yes or no? This wave will start traveling, right? This is a function of space and time both. So in space, this wave will start traveling in positive z direction. The direction is not important here. One thing we know that it will start traveling. And one thing from these two graphs we get to know that in 2 pi by omega time, it covers a distance of 2 pi by beta. So what is the velocity? Distance upon time. What is the distance? 2 pi by beta. What is the time taken? 2 pi by omega. What will be the answer? Omega by beta. V equals to velocity. Okay. This is known as phase velocity. So as of now, you don't need to think, sir, what is phase velocity, what is group velocity. Other term is group velocity. So when we study waveguide, there I will explain you in detail what is the difference between phase velocity and group velocity. So as of now, every velocity is the same for you, which is phase velocity only. So phase velocity is equals to omega by beta. Third formula you have got. This formula, and this formula. These three formulas you have got from this expression. So if this expression is given in front of you, E naught cos omega t minus beta z, will you be able to tell me the time period? 2 pi by omega. Will you be able to tell me the wavelength? Yes, 2 pi by beta. Will you be able to tell me the velocity of this particular field? Yes, omega by beta. That's it. Okay. So these will be highly used in the next lecture, but we are already checking the meaning of the waveform. Like in the next lecture, what you are going to do, you are going to derive the EM wave equation. So only this expression will come out. The expression of VM wave will be like this. So there I am not going to teach you how to study this particular waveform. This particular waveform we are already studying. Why we are studying this waveform? Because in the next lecture we are going to obtain it. So if you already have the idea of this waveform, then derivation will be easy. If I had directly started from the derivation, then you wouldn't understand a single thing about that. But in the next lecture, you will see that you are going to understand every single thing about the derivation. And without even doing the derivation, you will be able to write down the equation as well. That I can write you on the paper. After that 20 minutes of the next lecture, you will be able to write down the equation as well. Okay. So yeah, lambda formula you got, time period formula you got, and in 2 pi by omega time, you are traveling a distance of 2 pi by beta. That's why this is your velocity. So Vp equals to omega by beta. This is something you need to remember. Right? Yeah. So let's see this question now. E equals to, now I have added this AX cap. So first question and second question, two questions are there, both are different question. Okay. First question is saying, in which direction E wave is traveling? Second question, in which direction, what is the direction of E vector field? Two questions are there. In which direction E wave is traveling? This vector wave is traveling. Okay. This wave is traveling. In which direction it is traveling? It is traveling in positive z direction. We will prove it. And what is the direction of this vector field? That is along x-axis. So you might not be able to understand all these things. I will make you understand. Do not worry about it. So first, let's come to the first question. In which direction this wave is traveling? So I just need to know the direction of the wave. That's it. So I am dropping the AX term here. So for the first question, this is the expression of E I am writing. I am not interested in which direction my E field is. I just need to know where it will travel. I will show you the simulation as well. You will be more comfortable after that. Okay. So what I need to know, I just need to know where it will travel. Okay. So at different time instant, I will see my waveform. We saw this example now, fx equals to x plus t. What we did there? We took the different values of t, right? What we did at t equals to 0. Arey yaar. At t equals to 0, then at t equals to 1, then at t equals to 2. So we took the different values of t, and then we got to know that it is traveling in this direction, right? So same thing we are going to do here. This is my scalar field, you can say, because ax cap I have removed. E naught cos 2 pi by t into t minus 2 pi by lambda into z. This I can write, right? Because omega is 2 pi by t and beta is 2 pi by lambda into z. Now different values of t I am gonna take. So at t equals to 0, what will be my expression of E? That will be omega E naught cos minus 2 pi by lambda into z. So that will be E naught cos minus theta is equals to cos theta only, 2 pi by lambda into z. At t equals to t by 4, what you will get? At t equals to t by 4, what you will get? If you put t by 4 here, E naught cos t by 4 pi by 2 minus 2 pi by lambda into z. So cos pi by 2 minus theta, what is that? Sin theta. So E naught cosine 2 pi by lambda into z. And at t by 2, what you are going to get? E naught cos t by 2, that will be pi minus 2 pi by lambda into z. Cos pi minus theta, what is that? Cos pi minus theta, that is cos theta only, but in the second quadrant cos is negative, right? Cos pi minus theta, second quadrant. If you go to cos, what are you? Positive or negative? Negative. All student, so negative. So this we have seen in the basic lecture only. So these are the three waveforms I need to draw. So can I draw the waveform of E naught cos 2 pi by lambda into z? With respect to z, I will draw. So this I am drawing E naught, this I can call as E1, E2, E3. So this is my E1, this is my E1, this is my E2, and this is my E3. This is actually the negative cos, no? T by 2 I need to put, t equals to t by 2. So if I put t equals to t by 2 here, so pi minus theta you get, this is the correct expression, but this waveform is wrong now. Okay. So let me pause the video and make the waveforms. Like basically I am making the waveform now. This is your cos theta, then this is your sin theta. Next one will be your minus cos theta, but here I drawn minus sin theta. So that was an error from my side. So I will draw minus cos theta. So it is very tough to draw actually on writing pad. So better I will pause the video and draw these waveform in a better manner. So I will pause the video now. Yeah. So these are the waveforms. And can you tell me what will be these values? So this waveform is E naught cos 2 pi by lambda into z. E naught cos 2 pi by lambda into z. So at z equals to 0, at z equals to 0 you are having magnitude 1. At z equals to lambda by 2, at z equals to lambda by 2, what will be the magnitude? Cos pi. If you put z equals to lambda by 2 into lambda by 2, what you are going to get? 2 and 2 get cancelled. Cos pi, that is minus 1. So this is your lambda by 2. This will actually be your lambda by 4. This point will be lambda by 4. This point will be 3 lambda by 4. This point will be lambda. This point will be 5 lambda by 4. And in that manner it will keep on going. Okay. So same you can draw for this as well. This will be 0 and this point will be sinusoid it is. So this point will be lambda by 4. The same coordinate it will have. This is lambda by 2. Same goes for this one. This will be lambda by 4. This will be lambda by 2. And that manner it will go. But what this waveform is representing? When you click the photo on t equals to 0, this is what you got. When you click the photo on t equals to t by 4, this is what you got. And if you click the photo on t equals to t by 2, this is what you got. So what did you understand? This was the peak here, right? Now this peak was at this point when you clicked the photo at t by 4. This peak was at this point when you click the photo at t by 2. So this peak is moving not only peak is moving, complete waveform is moving, you know. Basically this 0 was here, now it is here, then afterwards it is here. This 0 is also moving. This negative -1 it is here, then it is here, then it is here. Every single point is moving. This point is here, it is here, then it is here. So complete waveform is moving towards a positive z axis. That's why we said that it is walking around positive z axis. So the wave is traveling around positive z axis. Did you understand this point? Here also you could have said that sir, if I took the photo at t equals to 0, if I took the photo at t equals to 0, this is what I got. If I took the photo at t equals to 1, this is what I got. If I took the photo at t equals to 2, this is the waveform that I got, right? Similarly, when I took the photos, what did I get to know? That my wave is actually traveling like this. This peak is moving. So wave is traveling like this. In the end, I will show you the simulation as well. More clear it will be. But wait till the end. The complete picture is still remaining. This is one of the points that you have covered. That it is moving along z-axis. Also, by our previous analysis, also we know that if signs are opposite, then certainly it will be moving around plus z-axis. But here, for your convenience, for your inner satisfaction, we have drawn this waveform as well. That my waveform is actually moving. It is not constant. At t equals to 0, this is the waveform. And then we got to know that it is actually moving. Right? Till this point it is clear. Now second and third question we will see together. What is the direction of E vector field? In the third question they are saying that you need to draw the E field at a fixed time. So now I will again fix the time and I will draw the E field. So let's understand what we are saying. So what we are saying, we will fix the time. Let's just say first I will fix the time at t equals to 0. So now I will click the photo at t equals to 0 and I will see what do I get along z axis. Are you getting this point? Basically, now I need to draw my vector field. So at t equals to 0, I am clicking the picture. At t equals to 0, I am clicking the picture. So along z axis, what do I see? That I need to check. So you are not able to understand this point, but slowly when we go into mathematics, you will understand it. So I am fixing the time at t equals to 0. So at t equals to 0, I am going to see this waveform. So at t equals to 0, if I put t equals to 0, what is the expression of E I am going to get? This is t equals to 0, so minus sign will, cos will eat up. So you are going to get E naught cos 2 pi by lambda z Ax cap. So now it is my vector field. This was your scalar field. This was your scalar field. Now you are making it a vector field. Okay. So now let's put z equals to 0. With respect to different z, how do I get my waveform? That I need to check. If I put z equals to 0, what do I get here? Cos 0, 1, E naught Ax cap. So in x direction, you are having a vector E naught Ax cap. So if I say this is my x direction, if this is my x direction, so in the x direction I am having a vector E naught. Then lambda by 8. At lambda by 8, this was at z equals to 0. Z equals to 0. At lambda by 8, if you put lambda by 8 here, what you are going to get? Cos pi by 4, that is root 1 by root 2. So E naught by root 2 Ax cap. So at lambda by 8, what we are having? E naught by root 2 Ax cap. So direction is same, E naught by root 2 Ax cap. Do you remember how did we plotted the vector field? Now we are plotting the vector field, right? Now z equals to lambda by 4. If you put lambda by 4 here, what you are going to get? Pi by 2. So what is cos pi by 2? Cos pi by 2 is 0. So here I am getting 0 at lambda by 4. In that manner I am going. So at 3 lambda by 8, what you are going to get? Minus E naught by root 2 Ax cap. Okay, this you can see on your own. At lambda by 2, what you will get? अरे यार E naught क्यों लिख दिया यहाँ पे? E vector at lambda by 2 minus E naught Ax cap. So similarly in that manner you can check on your own. 5 lambda by 8. So you will get minus E naught by root 2 Ax cap. These values you can check certainly. Then you will get 0. At lambda by 4 I was getting 0, not E naught, sorry. Here I was getting 0, not E naught. Here I was getting 0 at lambda by 4. Cos pi by 2 is 0. So here also I will get 0. And at 7 lambda by 8 I will get E naught by root 2 Ax cap. And at lambda, at z equals to lambda, again I will get this thing, right? At z equals to lambda, again I will get E naught Ax cap. So this was your rough waveform. So let's remove the rough waveform and let's make the fair waveform. So this is how your fair waveform will look like. This is not E, this is the x direction, this is the x direction. Magnitude of E, in x direction you are having E naught ax cap, then you are having E naught by root 2 ax cap, then you are having 0, then you are having minus E naught by root 2 ax cap, then you are having minus E naught, then minus E naught by root 2 ax cap, then 0, then again E naught by root 2 ax cap, and then again E naught ax cap. So starting with 0, time window I am going to write now. So let's remove this amplitude. 0, lambda by 8, lambda by 4, 3 lambda by 4, lambda by 2, and then what is this? Lambda by 8, lambda by 8, lambda by 8, 3 lambda, 1 lambda by 8, 2 lambda by 8, 3 lambda by 8. It was a 3 lambda by 8, sorry. This was 3 lambda by 8, 4 lambda by 8, 5 lambda by 8. So in that manner we are going. So what did you understand by this point? At t equals to 0, when you click the picture, you thought that you are getting a constant waveform. No, there are vector fields. This vector field I plotted at 0 and lambda by 8. In between, lambda by 12 will also come, no? In between, lambda by 12 will also come. Here in between some other things will also come, right? Here also in between some other things will come. Here also in between some other things will come. In that manner things will keep on coming, no? So there are vector fields like this. There are vector fields like this, and they are going in terms of cosinusoid. It feels like that vector fields are going in cosinusoid form, right? It feels like a cosinusoid form. So vector fields are going in cosinusoid form. What else you can observe? That this is at t equals to 0. When I increase time t, when time t increases, this vector field will move along z axis. When time t increases, these vector fields will move along z axis. Say yes or no? Because I know as the time increases, my waveform moves along z axis. Here I did not draw the vector field. Actual my E field was this. So this is not the graph of actual vector field. Now I am drawing the actual vector field. So I have drawn the actual vector field at t equals to 0 only by putting these the value of z. So then I got to know that I am having these vectors. I am having the packet of vectors in this manner. And when this was the time at t equals to 0. And when I put the time button at t equals to 1, 2, 3, 4, this will start moving. And let me show you the simulation now. I will pause the video. I will show you the simulation. Yeah, so let's see the simulation. Again, before showing the simulation, credit goes to opophysics.com. So I am taking from their website. This is not something that I created on my own. I am taking from their website. So this was the vector field that we created. But this was at time t equals to 0. And just I start seeing it with respect to time. There you go. So this is how the field will travel. You see one peak. Any peak you pick up. Let me stop it. You pick up this peak. Okay. You pick up this peak. Are you able to see my cursor? You pick up any, you just keep your eyes on this particular peak. Which peak I am talking about? You keep your eyes on this particular peak. You will realize that this peak is moving. The same peak is moving towards z axis. You will realize that. Okay. Just keep your eyes on this particular peak. Look, this peak is moving. It is moving very fastly actually. So you are not able to visualize it, but you can see this peak is moving. So all these waveforms are moving along, let's just say this direction was my z axis. If this was my z axis and this direction is x axis, right? What I mean to say is that this is my x axis and this is my z axis. This is my z axis along which it is moving, and along x axis there was my amplitude. So this was my actual waveform, right? Let's get back to our conceptual part. So let's get back here. Yeah. So this waveform which I drew, this was not completely correct because I dropped ax cap there. When I connect ax cap, I get to know that I am having a packet of vector fields which is moving along z axis. So are you able to understand this complete equation? E naught cos omega t minus beta z ax cap. Do you understand everything about this equation? It's a time harmonic vector field. Time harmonic vector field. Time function of space, cos, time harmonic vector field. The wave is traveling in positive z direction, but the direction of field is along x-axis. So these are along x-axis, positive x-axis or negative x-axis. So the direction of the field is in plus minus x direction. Sometimes it is along plus x, sometimes it is along minus x. So from here, what did you get to know? That your E field is along x direction. So I would say plus x direction only. E field is along plus x direction. What is the time period of it? 2 pi by omega. What is the phase constant? 2 pi by beta. Sorry, phase constant is beta. Sorry, not 2 pi by beta. And what is the wavelength? 2 pi by beta. And what is the velocity? Omega by beta. So this is the summary of the second half. That's it. This is what we studied in the second half. And one thing, this very important. This is how the wave is traveling. So when I write down this equation, what should come in your mind? That something is traveling like this. Okay? Some vector fields are traveling like this in z axis. This should come in your mind as soon as you see this equation. If you have this much of visualization, I am trying my best to give you every single possible visualization. I hope you are admitting this fact as well. So whenever I say the things, this should come in your mind that the wave is traveling in this direction with these vector fields. So this is a very complex part of EM wave. Like people do not understand anything here. Okay, they will just mug up some formula and EM wave is completed. But no, it's all about visualization. It is the most beautiful chapter of electronics. So we are going to study in that manner only. I hope you are getting to know. So this was the summary of second half. The summary of first half I have already given. Phase constant. Phase constant. Like phasor of a vector field, phasor of a time harmonic vector field. Okay, so that phasor we saw, and then we saw the differentiation. And from the vector field we saw how to write down the, from the phasor we saw how to write down the vector field, right? So these things we saw, and the important part was how to write down these equations. And these equations we will always write down in phasor, because del cross E is equals to minus j omega h is only applicable if your function is something like this. If it is some cos omega t minus beta z, then it will not be applicable. This is a very good question. These kind of questions you can expect in your examination as well. So yeah, that was a good discussion, I hope. And if you found it helpful, you can certainly like it and share it with your friends. Thank you very much. Let's meet in the next lecture. There we will see the solutions of EM wave. Thank you very much. Solution of Maxwell equation, and we will generate EM wave. Thank you.